The Systems Development Lifecycle SDLC is a way to deliver efficient and effective information systems that fit with the strategic business plan of an organization. The SDLC can occur within an organization, be outsourced, or be a blending of the two. If you have been practicing in healthcare for any amount of time, it is likely that you have experienced the integration of an information system and/or an update in one. This includes changes within an electronic health record system or a part of the administrative, clinical, or educational information systems within your organization. These updates can include minor changes or implementing an entirely new system. The best integration of updates or changes involves implementing a process. This is where the systems development lifecycle comes into play. There are different methods for implementing systems development lifecycle. The waterfall model method is one of the oldest methods and depicts a waterfall effect. The output from each previous phase flows into or becomes the initial input for the next phase. The waterfall model is a sequential development process because there is one pass through each activity from conception or feasibility through implementation in a linear order. The waterfall method breaks down the process into 6 phases. The first phase is feasibility, which asks if the project should be initiated and if it is supported. The second phase is analysis. This reviews the needs of the organization. The third phase is design, focusing on high and low level data design and the details involving the team members. The fourth phase is implementation, where the design is brought to life through programming. The fifth phase is testing the product and integrating it into the system. Finally, the sixth phase is maintaining and offering user support. The rapid prototyping or rapid application development or RAD method provides a fast way to add functionality through prototyping and user testing. Technology updates can be difficult to comprehend in theory. This method allows early use of prototypes. It is easier for users to examine actual prototypes rather than just reviewing the documentation. In this method, a rapid requirements gathering phase uses workshops and focus groups to build a prototype application using real data. The prototype is then beta tested with users, and their feedback is used to improve the system. The Object-Oriented Systems Development OOST method combines the logic of the SDLC with the power of object-oriented modeling and programming. It attempts to represent real-world objects like the clinic, patient, or nurses into abstract computer software objects. Once the system is object-oriented, all interactions or exchanges occur between the objects. This allows for a highly interactive approach. The Dynamic System Development Method DSDM is a highly iterative and incremental approach with a high level of user input and involvement. The iterative process requires repetitive examination that enhances detail and improves accuracy. This method involves 3 phases: the pre-project phase, the project lifecycle phase, and the post-project phase. The pre-project phase involves the stakeholders and raising support. The project's lifecycle phase involves 5 steps: feasibility, business studies, functional model iteration, design and build iteration, and implementation. During the final phase, labeled post-project, the team ensures the system is functioning properly. The Agile software development approach is different from other approaches to software development since the focus is on the people making up the teams that are doing the work and how they work together to complete their tasks. This method merges iterative and incremental process models. It breaks the product into small incremental builds so teams work in short bursts, such as 2 to 4 week intervals, to accomplish their tasks. In this method, failure is considered positive if you fail fast and fail often to get to your goal. When reviewing the system's development lifecycle, the computer-aided software engineering tools can be used. This automates many of the tasks required in a systems development effort and encourages adherence to the SDLC. It instills a high degree of rigor and standardization to the entire systems development process. The tools help to reduce cost and development time. When reviewing the system's development lifecycle, interoperability must be considered. The ability to share information both within and across organizations remains paramount. The system's development lifecycle SDLC plays a vital role in the successful implementation of information systems in healthcare, ensuring that updates and new processes align seamlessly with organizational objectives. By mastering various SDLC methods and their applications, healthcare professionals can significantly improve information system integration and ultimately enhance patient care outcomes.